What's up, guys? Alexander here, Date Psychology. So today I want to talk about sampling, convenience samples, random samples. How are they different? And maybe some applications for the real world. I think sometimes people get some misconceptions about these. So going forward here to the first slide, this is an example. Random sampling. You have a population, whatever that is. Let's say it's the United States, for example. And you want to know how common something is in the population, right? You want to sample from that. You can select from that population randomly, and you should get a sample that represents that population pretty well, right? So that's the thing to understand. Random samples of a population will reflect the characteristics of that population. A basic thing in statistics, right? A fundamental for understanding how can we learn things about everyone from just a small group of people that we select, right? So random sampling is used for that. Pretty important. Let's go on to the next slide. Does this work? Well, we can test it, right? We know that this works. Okay. This is kind of a simulation that I ran in R, and I made a population mean of 50, sample size 360 million. So why 360? Kind of, the size of the United States, more or less, right? The whole population. Then with a sample of only 300 people in the first sample, what is the mean? 50, right? And you can see in the second part of this slide here, it's a histogram across 20 separate samples randomly selected from this population. What are the means that we get? They're between 48 and 51. So they're very close to that mean. This is important because I think a lot of people think if a population is huge, right, you need a large sample, right, to reflect that population. Not often the case. There's a link, or I should say just a screenshot, right, of an article I wrote about this. No, the sample size is not too small. That explains, you hit about 300 people sampling the whole population of the United States, for example. That's when you start to be pretty accurate as far as what can you infer. But this only works with random sampling. So let's go forward and see. We have some pros, right? We know that a random sample is going to be representative of the population. This also means you can generalize from your sample to the population. And because everyone in the population has an equal chance of being selected, there's a lower chance of bias, right? You're not selecting a certain type of person. Anyone can be selected. And as a result, your sample is going to usually be pretty representative of the population. At least that's the idea in an ideal circumstance. But let's go forward. There's some cons of this as well, right? One is that you probably often don't have access to the entire population, even if the population is known, right? Say you want to learn something about the whole population of the United States. You might not be able to get a random sample of the whole United States regardless, okay? No matter what you do. So there's that. It can be inefficient. It can be very expensive, but it could also be impossible in a literal sense, because let's say your desired population is not just all Americans. Let's say it's psychopaths, right? Do you have access to all of the psychopaths in the world? You don't, right? You don't even know who they are. So you want to learn about psychopaths. You're never going to have a random sample. You got to use the psychopaths that you have at hand. Who are those usually? Usually they're going to be people in jail. A lot of research on psychopaths. Criminals that have been incarcerated. But then you have a problem, don't you? Because psychopaths who have been caught and incarcerated might also be a little bit different from those who have not. So you have this convenience sample is what it's called, right? Psychopaths in jail. And that's kind of how we learn about these people. But are they reflective of all psychopaths everywhere? Maybe in some ways, yes. Maybe in other ways, no. But let's go forward and see. This is an example of non-random sampling in the next slide. So this is for height. Let's say we just took a sample from the general population, right? Let's say this is random. And so we see, okay, 14% of the general population, real figure, is 6 feet tall or above. And then we have another sample, just basketball players. And this is not a random sample, right? You just say, okay, I'm going to measure all the basketball players from my local college team, okay, from the high school team or whatever. And you say, okay, 40% of these guys are 6 feet or over. From your sample of basketball players, would you then say, okay, 40% of everyone is over 6 feet? Obviously not, right? You don't have a random sample. You have a sample of a specific population, and that's only going to be reflective of that population. Maybe you could infer something about basketball players. Even then, the basketball players you sampled, they could be different from other basketball players, right, on a different team. But it's probably going to be closer to basketball players in general than it is to the general population. And this reflects how most samples of human subjects across any field, not just psychology, are recruited, okay? It's basically the people that you have on hand. Convenience sample. So given that we know most samples of human subjects are not random, how many? About 95% of all samples used on human subjects are convenience samples, okay? People select who is at hand, and that's how we learn about human psychology, human physiology, biology, all of that, okay? The main limitation is generalizability, right? You can't assume that your sample is reflective of the population, but that doesn't mean that it's not either, right? Does it mean that we can't learn about the world from these kinds of samples? No, it doesn't mean that either. So given that, we need to look a little bit further. Let's go on to the next slide. How, to use an example here, did we learn about brains, right? Did we take a random sample of Americans or the whole world and say, okay, this is how all the brains work and all the human beings, we know that because we have a random sample? No way. It began with case studies of lesions, right? A handful of people, 3 or 4 people. We said, yeah, they have lesions in their temporal lobe. They all have memory deficits. Maybe the temporal lobe has, a role in memory. Turns out that's the case. And this is typically how, a lot of clinical research continues to work today. Small samples, not representative, taken from clinical populations, people from hospitals. But it works, How do we know that it works? Okay, because we can compare these samples with one another. So you take a sample from one hospital, individuals that have these lesions, temporal lobe. Would you assume it's just this hospital? Probably not, just, a priori, beginning from zero. You would probably think, no, that's probably how brains work. But you wouldn't know, would you, unless you had something to compare it to. So let's go forward and kind of look a little bit more. Brains are not really a special case here, okay? You might think that, okay, all the brains work the same, and they don't, by the way, but you might think all the brains work the same because it's biology or something like that. And I say they don't, but there are obvious similarities, but there's differences as well between populations, important. So brains, not a special case. Here's a slide. This is looking at different samples, convenience samples and representative samples. TESS here is the representative sample. Then you have a student convenience sample, you have a staff, and you have MTurk, which is an online sample as well, okay? So you can see here, very close. And these are political attitudes, okay? Things that you would expect to be pretty different, but they're actually not that different. The second image here is 20 separate experiments across political psychology that show the results from the representative sample and the results from the MTurk, right? The online convenience sample. You can see, in black and gray here, very, very similar results. So it is often the case that even if you're using a convenience sample, yeah, you're gonna get results that you will be able to replicate if you use a representative sample, which is important. Replication, we're gonna talk about that in a slide here. When is having a representative sample more important? And when is it less important, perhaps? So one is when you want to estimate frequencies within the population. And this is something we looked at in our basketball player example, didn't we, right? That if you don't have a representative sample of the US population, you're sampling a bunch of basketball players, you're going to get an estimate for height that is much higher than it is for the US population. So if you're working in, demographics or something like that, if you're doing political polling for voters, that sort of a thing, yeah, pretty important. When is it less important, on the other hand? Well, if you're comparing groups, right, men versus women, you will find a lot of things replicate across convenience samples that have rarely even been tested with representative samples. Why? Because regardless of the group that men and women belong to, there's going to be differences between men and women, right? And you can see these sex differences replicated consistently. Additionally, when you're looking at these, what have been called in the past kind of universal cognitive mechanisms, does attention work the same in most human beings? Seems to. Does it work the same in, memory in most human beings? Seems to. And it's not just, cognitive psychology, but there are personality differences associated with, different things that you will be able to replicate consistently across groups. So let's go on to the next slide. I've mentioned this throughout the video, replication, sampling. How do we know, right? So we take a convenience sample, we get a result. How do we know that that applies anywhere else in that case? All you can do at that point is try to replicate it, right? With a different sample. So you take a sample of students, right? And you find, okay, we have a sex difference in sociosexuality. Cohen's d of about 0.9, which is consistent across the research. And that's what you see in the student sample. And you say, but would this be true if I survey older adults who are not students, or if I survey people who drop out? So you can get a sample from that other population. It's not going to be a representative sample, but then you can compare that result. And this is typically how it works, right? Across, behavioral sciences. You're not comparing necessarily with representative samples. Occasionally you get them and they pop in there, but you're seeing replication across convenience samples that are not representative. And this builds up kind of a base of evidence, doesn't it, over time, saying, okay, yeah, in this population it exists, in that population it exists. This one it does too. We're seeing these sex differences consistently. Can you infer something from that? Yeah, not based on the randomness and generalizability, but based on that line of evidence kind of that you have created. Let's go on to the next slide. Samples, convenience samples. Where do most of these come from? Like I said, I think a lot of people have a wrong impression that like random samplings are really common. As I mentioned, in the first paper, about 95% of samples of human subjects are convenience samples, not random samples. So where do we get most samples? I think the top way now is still college undergraduates, right? If you're running experiments in a university, and if you're running experiments, you probably are in a university, right? You're a grad student, professor, or whatever. You're recruiting samples from your students, or at least from people, in your area of the college. Often they have to participate for credit, right? And if you've been a psychology student, you probably know this, that you might have to sign up to a platform and pick like a study to participate in. So that's one way. Another way now is these online sampling platforms, right? Polling platforms. You have one called Prolific, MTurk. There's probably some others out there. And these are basically people that take polls, surveys for money, okay? So that also gives you, another convenient sample. Social media is being used increasingly. Researchers put their surveys, on Facebook, and then they say, hey, or Twitter or something like that. They say, hey, retweet this, share this with your friends. So that's a convenient sample. It's also called snowball sampling. Why is that? Because, like a snowball is rolling. It picks up more snow and it gets bigger. You give, your survey to someone. You say, hey, share this with your friends. Tell them to share it. They share it. The friends share it. So eventually you get this sample that's just kind of manifesting itself. There's some criticism about these samples, demographics, right, that have been called, the weird effect, right? They're Western, educated, industrialized, rich, and they're democratic. So, if you're trying to infer something from Western populations, about the Himba in Africa, maybe there are some differences there. But even then, you do actually see, particularly in research on sexual behavior, things that are replicated, in Western populations that even apply to these very, very different populations. So there's also another question there, which is how much do you care, right? If you are primarily interested in Western populations, right, does your sample need to be generalizable to external populations? It's kind of like if you're interested in Alzheimer's disease, do you need a random sample with like a bunch of healthy participants and you're trying to, give people a drug and saying, how well do they respond to this drug? You actually kind of want a homogeneous sample of people with Alzheimer's disease to see how well they respond, right? You're not going to give it to people at different stages perhaps and say, okay, they don't respond here. I mean, there are reasons actually that you don't just want, a broad representative sample of the entire population. And if you're studying something like relationships and dating, and particularly if it's interesting to you, well, you live in a Western country, maybe, not all of you watching this, but many of you do. So, the results of like, college students, mean age 24, Western, et cetera, that's a population that's probably pretty applicable to you. So as far as like, does this generalize to geriatrics in a nursing home? Like, do you even care? That's another question that you have to ask. Let's go on to this next slide. There's something that I see a lot of people do online as someone who, kind of writes about science now and tries to make these things, accessible to a general public, is people see that a sample is not representative and they say, oh, I'm not going to believe the results then. Okay, well, you don't have to believe anything that you don't want to. Knock yourself out. Every paper has a section called the limitations section. And in this limitations section, they, report this. Here's an example, from this slide. Limitations and strengths of the BBC data, okay? The BBC data had a number of limitations that are worth noting. For one, they were not drawn from a probability sample. That's something you're going to see in 95% of the papers out there. Why? Again, because most samples are not random or probability samples, are they? They're convenience samples. So when you see something like this, Important to understand, you haven't discovered anything new. You know, this isn't like a home run for like, I don't want to believe the results. If you're bringing this up, it's more likely that you simply don't like the results, right? You're manifesting a cope, so to speak, right? Like, oh, I don't want to believe it unless it's a representative sample of 10,000 people and da-da-da-da. Okay, well, you need something more than that. You know, you need to show kind of that it doesn't replicate. You would need to show that, you know, this sample was biased in such a way that it produced results that are different from what we see across all of these other samples, right? So, you know, I see that sometimes. We can use an example, sometimes some feminists online, you point out sex differences in libido, right? The libido gap. Very well replicated, okay? But you post a paper on the libido gap, it says, you know, 90 college students, and they say, oh, well, these are college students. They might be different. And it's like, okay, yeah, maybe, but this libido gap research is replicated across populations, not just in college students, right? In elderly individuals, across cultures, et cetera, et cetera, et cetera. Now, here, let's go on to the next slide. These are not all, you know, representative samples. Most are not. You're replicating across samples that are convenience samples, but you're seeing consistent results. And that's basically what you want to look for. Anyway, that's the reality on the ground, guys, is that, you know, if you came out of Stats 101 and you learned, like, I need a representative sample so that I can generalize to the population. Okay, there are times when this is important, but, you know, when you get, you know, to the point where you're conducting research and you have to actually acquire a sample, that goes out the window, is what I'm going to tell you right now. You know, maybe you can do it. Maybe you can get funding to do it and hire, you know, a company that has access, you know, to some kind of polling thing, and they can get you a random sample. Even then your sample is going to have bias, won't it, right? Response bias. Not everyone's going to respond. So already you're excluding people. There's no truly generalizable, truly perfect sample. In that case, some are better than others. And if you think, you know, that a sample produced an erroneous result or a different result or something like that, the only thing you're going to be able to do is look at other research, past research, future replication attempts, and then say, okay, this is inconsistent with those results. Maybe it's inconsistent because their sample was different, right? But if it's consistent with all of those results, you know, then what are you saying? Like, I'm not going to believe any of these samples across all of these different populations because I don't like the result? Yeah. Quotation here from Kish, who's a famous statistician, I suppose. I'm not that into historical statisticians, I suppose. But he said, great advances of the most successful sciences, astronomy, physics, chemistry, were and are achieved without probability sampling. No clear rule exists for deciding exactly when probability sampling is necessary and what price should be paid for it. Probability sampling for randomization is not a dogma, but a strategy, especially for large numbers. Something to keep in mind, okay, that ideally, in an ideal world, something like this might be the gold standard. But when you are on the ground trying to conduct research, you need to collect samples. There's a maxim in statistics and research, you know, where they say the best sample is the sample that you got. And that's what it comes down to at the end of the day. Anyway, hope you liked the video. I'll make another for you very soon.